Okay, so you ever stop and really think about what happens to all your stuff online? You know, the photos, the documents, everything.
Yeah, it kind of just goes somewhere, right?
You
Into these massive server farms owned by just a few big companies.
Exactly. And you're basically just trusting them to keep it safe, keep it accessible. It feels a bit precarious sometimes.
It really does. And that's why this whole idea of decentralized storage is getting so much traction. It's a pushback against that central control model.
Right. Distributing the data instead of keeping it all in one or maybe a few baskets. Which leads us nicely into today's deep dive.
We're looking at IPFS, the Interplanetary File System.
Yeah, IPFS.
Yeah.
And our goal here, drawing from the IPFS storage AIOZ Pin docs, isn't to drown in the super technical weeds.
No, definitely not. We want to get the core ideas, understand why people are excited about it, especially for things like Web3 and NFTs.
What are the key takeaways? What's the aha moment here? That's our mission.
Exactly. Understanding the shift, what it means practically, without needing a computer science degree.
Okay, let's dive in. The IPFS protocol itself, what's the fundamental change here compared to, the regular internet we use every day?
Well, the biggest thing, really, is how it finds stuff. Traditionally, we use location addressing. You type in a website address, a URL.
Like www.something.com.
Right. And your browser goes looking for that specific server at that specific location. IPFS flips that completely. It uses content addressing.
Content addressing. Okay, so instead of asking where is this server, you're asking.
We're asking, give me the data that looks exactly like this, regardless of where it's stored.
How does it know what this is?
That's the magic of the Content Identifier, or CID. Every single piece of content, whether it's a tiny file or a whole website,
It's a unique ID.
gets a unique ID, yeah, a CID. And it's generated directly from the content itself using cryptography. Think of it like a fingerprint.
A digital fingerprint. So if I change even one tiny bit of the file.
The fingerprint changes. You get a
Okay.
totally different CID. And that's absolutely crucial for security and knowing your data hasn't been tampered with.
Okay, that makes sense. So you have these unique fingerprints, these CIDs. How does IPFS organize it all? It's not just a random pile of fingerprinted files, right?
No, no, not at all. It uses something called directed acyclic graphs, or DAGs. It sounds complicated, but you can sort of think of it like linking pieces of data together.
Like how a big file might be made of smaller chunks.
Exactly. DAGs help structure that, linking the chunks together efficiently, making it easier to navigate and retrieve things without storing redundant copies. It's quite clever.
All right, so there's structure. But if the data's spread out everywhere, how do you find the specific computer that has the content for the CID you want?
That's where distributed hash tables, or DHTs, come in. Imagine a massive shared phone book, but instead of names and numbers, it maps CIDs to the network addresses of the computers, the nodes storing that content,
And this phone book isn't held by one company, it's spread out too.
spread across potentially millions of computers participating in the IPFS network. It lets you find who has what content without needing any central directory.
Okay, wow. So stepping back, what are the big wins here? Why go through all this effort to change how we store and find things?
Well, the benefits are pretty significant. First, data ownership and control. It shifts things back towards the user, away from relying solely on big platforms.
Less dependence on, say, Google Drive or Dropbox, staying online or keeping their policies the same.
Right, and then there's resilience.
Yeah.
If your data is stored on maybe 100 different computers and 10 of them go offline.
It doesn't matter, you can still get it from the other 90.
Exactly. That means high availability, fault tolerance. Plus, you can often retrieve the data faster because you can pull it from a node that's geographically closer to you.
And that, you mentioned, is why it's so interesting for Web3 stuff like dApps and NFTs.
Precisely. It provides that robust, decentralized foundation they need.
Okay, let's drill down into that NFT connection then. We hear NFT stored on IPFS all the time. What does the CID actually do for my digital cat picture NFT?
Right. The CID is absolutely core to making NFT storage secure and, importantly, immutable, unchanging. That cryptographic hash we talked about, the fingerprint, that CID is often what's actually recorded on the blockchain as part of the NFT's data. It points directly to the image file, or the music, or whatever the asset is.
So the blockchain entry basically says, whoever owns this token owns the rights associated with the digital thing that has this specific CID.
That's a great way to put it, yes.
Yeah.
And because the CID is derived from the content, you can always verify that the file linked hasn't been secretly changed or swapped out.
Ah, so it prevents tampering. Like, someone can't just replace my cool digital art with a picture of a potato after I buy the NFT.
Exactly. If they did, the CID would change, and it wouldn't match the one recorded on the blockchain anymore. The link would be broken, effectively. It acts like a tamper-proof seal.
Gotcha. So the CID is the decentralized address for the actual content, separate from the ownership token on the blockchain. No more broken image links because some company decided to reorganize its servers.
Precisely. It guarantees that data integrity changed the data, changed the CID. It makes addressing the content super efficient. And really importantly for Web3, it helps with interoperability.
Oh, so.
Because that CID is a universal identifier for the content. Different platforms, different marketplaces, different wallets can all recognize and correctly display the asset linked to that specific NFT, no matter where you move the NFT itself. It's like a digital passport for the content.
Okay, that really clarifies the NFT angle. But, the sources also mention IPFS being used much more broadly in Web3 apps beyond just collectibles.
Oh, absolutely. NFTs are just one, albeit very visible, use case. Think about decentralized finance, DeFi.
Right.
IPFS can store crucial documents, maybe the front-end code for a DeFi website or metadata about smart contracts, making the whole system more resilient.
Okay, what else?
Gaming. Storing in-game assets on IPFS means players can have true ownership, verifiable ownership, outside the control of the game developer's central servers.
Interesting. So your rare sword is really yours, probably.
Exactly. Or think about digital artists just wanting to share their work without worrying about censorship or platforms disappearing. IPFS offers a persistent way to do that, even things like supply chain.
Supply chain, how?
Well, you can use IPFS to store tracking data, certificates of origin, things like that, in a way that's transparent and incredibly hard to tamper with. Everyone in the chain can trust the data more.
Wow, okay. So it's really aiming to be a sort of foundational layer for a whole range of decentralized applications, not just NFTs.
That's the vision. It helps these dApps deliver content efficiently, scale up as they grow, and importantly, talk to each other, share data in this decentralized web. It's about building a more user-centric internet infrastructure.
Okay, but interacting with CIDs and DAGs and DHTs, that sounds maybe not super user-friendly for the average person just browsing the web.
Totally fair point. And that's where IPFS gateways come into the picture. They're essential.
Gateways, like an entrance ramp onto the IPFS highway.
That's a perfect analogy.
Yeah.
A gateway is basically a bridge. It's an IPFS node, part of the network, but it also understands regular web requests, HTTP.
So I don't necessarily need special IPFS software on my computer.
Not always, no.
Yeah.
You can often access IPFS content just using your normal web browser through a gateway. You typically use a gateway's web address followed by the CID of the content you want.
Ah, okay. So the gateway fetches the content from the IPFS network and then serves it to my browser like a regular web page or file.
Precisely. Services like AIOZ Pin, which our source material is from, they run these gateways. They have a public gateway anyone can use to look up CIDs.
AIOZ Pin public gateway, okay. But they also mention premium gateways. What's the difference? Why pay?
Good question. Premium gateways are usually tied to their pinning services. We'll get to pinning in a sec. The main benefits are usually about performance and reliability.
So faster speeds?
Often, yes. And more private access, potentially no traffic limits like you might hit on a busy public gateway, maybe custom configurations, and just generally more robust, reliable connectivity.
Right. So if you're building a serious app that relies on IPFS, you'd probably want a premium gateway for that stability.
Definitely. It smooths out the experience.
Okay. Gateways make it accessible. But you mentioned pinning. What's that about? If data is just floating around on nodes, couldn't it just disappear if no one accesses it for a while?
That is the exact problem pinning solves. Yes.
Yeah.
Pinning is absolutely crucial for making sure content stays available long-term on IPFS.
So what is pinning?
It's basically telling the network, this piece of content, this CID, is important. Keep it. You're instructing IPFS nodes, typically nodes run by a pinning service, to hold on to that data persistently, even if it's not being actively requested all the time.
It's like putting a digital thumbtack in it, saying don't garbage collect this.
Exactly like that.
Maybe.
It prevents nodes from deleting the data later to save space if it seems unpopular. Our source highlights two main reasons this is vital.
Okay, what are they?
First, obviously, long-term persistence. Without pinning, your data could eventually vanish from the network. Pinning guarantees it sticks around.
Makes sense. And the second?
Enhanced availability. When you use a pinning service, they usually store your data on multiple nodes, often spread out geographically.
Ah, so it's not just persistent, it's also faster to access because it's likely stored on a node near whoever is requesting it.
Precisely. It boosts reliability and speed. And, as the docs note, it helps applications scale if lots of people suddenly want your data. Having it pinned across many nodes helps handle that load.
Okay, wow. So let's try and wrap this up. We started with the problem of centralized data control.
Yeah, and how IPFS offers a decentralized alternative.
Then we dug into content addressing using those unique CIDs, those fingerprints instead of locations, crucial for data integrity, especially as we saw for NFTs.
Right, that tamper-proof seal idea.
Okay.
And its broader use in Web3 dApps.
Then the gateways, the bridges making IPFS accessible through regular web browser.
The on-ramp, yeah, public and premium options.
And finally, pinning. The thumbtack that ensures data actually stays on the network long-term and remains readily available.
You've got it. Those are really the key building blocks. Decentralization, content addressing with CIDs, gateway access, and pinning for persistence. Understanding those gives you a solid grasp of what IPFS is all about.
So hopefully for you listening, this deep dive has demystified some of the tech behind Web3 a bit. It paints a clearer picture.
Yeah, it's a foundational stuff for where the internet might be heading.
And maybe a final thought to leave you with. Think about that shift. Moving from knowing where data is stored to just needing to know what the data is, using its content fingerprint. How might that fundamental change from location to content really reshape how we all interact with information, how we think about ownership online?
It's a really different way of looking at the digital world, isn't it? Lots of possibilities there.